Hello, so in this video we will cover all of the questions from the midterm review packet related to Unit 5, which was our reactions unit. So that would be questions 25 and 26, but they both have multiple parts, so we'll go through all of these. Okay, so for question 25, the first thing we're going to do is we're actually going to classify these reactions, okay? So remember there are 5 different types of reactions that we discussed in our unit, okay? So let's just remember what they are. We'll jot them down up here. So our types of reactions, we had synthesis reactions. So the key for a synthesis reaction is you only have one product formed, okay? We also had the opposite of a synthesis reaction, which would be a decomposition reaction. And the giveaway for that was we had only one reactant. Okay, there were 2 types of replacements. So we had single replacement and double replacement. The difference being whether it was an element and a compound swapping spots or whether it was 2 compounds switching spots. And then last but not least, we had our combustion reactions. Okay, so those are the 5 types, and you have a lot more information in your unit packet if you need some more help with these, okay? But let's check out each of these individually. So if we look at A, I have 2 different elements combining together to form one product. So since I only have one product there, that makes this a synthesis reaction. That's my giveaway, that I just have one product, okay? Now if I look at B, I have one reactant breaking down to form this and this. So here's the difference. One thing breaking down, if something's breaking down, that means this is a decomposition reaction. And I apologize for the typo here. That should be a capital C, so it's chlorine, just for future reference. All right. Now next up, if we look at C, so here we can see I have 2 things on both sides of the reaction. So that knocks out a synthesis and decomposition reaction. But I have one element right here, and I have 2 compounds, and 1 compound, right? And on the other side, I have a single element and a compound. So this is a replacement reaction. What we have happening is the hydrogen, which is by itself, is going to replace the magnesium. So notice that we'll have hydrogen and chlorine together over here. And then the magnesium basically gets kicked out, so it's by itself. So again, the giveaway for a single replacement reaction is that we have an element and a compound on both sides of the reaction. So there's the one side, and here's the other. Okay, and again, a compound would need at least 2 elements together. So that's going to make C a single replacement reaction. If we look at D, here's a compound, but here's another compound, and on our product side, we have the same thing, 2 compounds. So let's look at what's happening there. I see that the calcium on the product side is paired up with the chlorine, right? And the potassium is paired up with the bromine on the product side, right there. So since I have 2 compounds swapping partners to make 2 new compounds, that's what's going to make this a double replacement reaction. Double because each of the things already has a partner. Everything's already in 2s. Okay, so again, the giveaway for a double replacement reaction is you have 2 compounds on each side. Generally, they're ionic. They don't always have to be, but that's the giveaway. You have 2 compounds on both sides for a double replacement reaction. Okay, and then last but not least, if we look at E, what I have here, the giveaway for a combustion reaction is you always have the same 2 products, those products being carbon dioxide and water. And what you actually have happening is you have what's called a hydrocarbon, groups of carbons and hydrogens together, reacting with oxygen only to form CO2 and water. So in other words, these 3 pieces, this, and this, will always be the same. The only thing that's going to change is what's in that first spot. So as long as you have those 3 circled in blue, that's how we would know this is a combustion reaction. Combustion is usually described as burning in air or burning in oxygen, essentially. Okay? So now we have them all classified. Let me get this work out of the way, and we'll work on our balancing. Okay, so when we go to balance, remember what you're trying to accomplish is making sure that you have the same number of each element on both sides of the reaction. Okay, so you have to look at each element individually, Generally, it helps if you work from the left to the right and save hydrogen and oxygen for the end. So let's look at A. I have 1 sodium on the left and 1 sodium on the right, so that's okay for now, but we're not going to write anything yet. I have 2 chlorines here and only 1 here. So the only way to fix that is to put a 2 in front, because that 2 would now apply for the chlorine, and I had 2 here. But that 2 also applies to the sodium. So now I have 2 sodiums on the product side, so I would need to put a 2 there as well. Your last step should always be to go back and double check that the coefficients you placed actually worked. So let's see. 2 sodiums, so that's good. 2 chlorines, 2 chlorines, so we are good. Remember, you can either leave this blank because that's implying that it's a 1, or if you would like, you're welcome to put a 1 there. Either is fine. They mean the same thing. Okay, so that first one is now balanced. So moving on to question 2. So, 2B, excuse me. So, looking at this one, I have 1 potassium here and 1 here, so that's okay. I have 1 chlorine here and 1 here, so that's okay. But here's the issue. I have 3 oxygen on the left and 2 over here. Now, there's no whole number I can put in the front, and it does have to be a whole number. So there's no whole number I can put in the front here to make 2 equal 3. So what can I do? Well, if 2 doesn't go into 3, I need to find a number that both of them go into. So both 2 and 3 will go into 6. So what I'm going to try and do is get 6 oxygens on both sides, and then we'll reassess everything. Okay? So if I want 6 oxygen on the left, I would need a 2 in front here, because 2 times 3 gives you 6. Remember, coefficients multiply. And to get 6 oxygen on the right, I would need a 3 here, because 3 times 2 is 6. Okay, so now if we assess everything again, I have 6 oxygen and 6 oxygen, but now let's check our KCl. I have 2 Ks, and I need to put a 2 there to give me 2 Ks as well. Now I have 2 Cls, so we are all done. When this is balanced, it would be 2, 2, 3. Okay, next one. Looking at this, I have 1 magnesium here and 1 magnesium here, so that's okay. Next, I have 2 chlorines here and 1 here, so let's fix that. I would put a 2 here to fix our chlorine. Now, I have 2 hydrogens here, and look, I already have 2 hydrogens there. So let's do one last check. 1 magnesium, 2 chlorines, 2 chlorines, 2 hydrogens, 2 hydrogens. So we are all done. Again, you can either leave the rest blank, or if you would like, you can fill all these spots in with 1s. Okay, now on to D. So, I have 1 calcium here and 1 here. 2 bromines on the left and only 1 there. So that's our first fix. Let's put a 2 there to fix the bromine. Now I have 1 potassium, but since this 2's here, that means I now have 2 potassium there. So let's put a 2 in the front. Now we checked our potassium, but our chlorine, we now have 2 chlorines here and just 1 there. So if we look at everything now, let's see how it works. And remember, even if you're in the middle of a problem, if you get stuck, just sort of recount everything and assess, and sometimes it works out. So we've got 1 calcium here, 1 calcium there, 2 bromines here, 2 bromines here, 2 potassiums, 2 potassiums, 2 chlorines, 2 chlorines. So we're all done. Again, this could be a 1, and so could that if you would like to fill it in. Last but not least, I have 4 carbons here and only 1 there. Okay, so let's first put a 4 there. Now make sure you're doing this one in pencil, and you'll see why in a minute. I have 10 hydrogens here and 2 here. So 2 times 5 gives us 10 hydrogens there. The oxygen is what makes this one pesky, because on the right side, 4 times 2 gives me 8 oxygen, and 5 times 1 gives me 5. So total, that's going to give us 13 oxygen on the right. The problem is, here's the only place I have oxygen, but there's no whole number I can multiply 2 by to get to 13. So here's where we run into an issue. And this was a trick that came up sometimes, but not often. And the trick is, if you can get every element to balance except for oxygen, if you double the coefficients you already placed and try again, it'll end up working out. So let's try that. Instead of 4 and 5, if we double both of those, 4 will become 8 and 5 will become 10. So let's do that. And now, if we reassess, we should be able to make this work. So let's look. I have 4 carbons here, and now I have 8 carbons here, so I would put a 2 in the front here, because 2 times 4 would give us 8 carbons. Now I have 2 times 10, so 20 hydrogens. 2 times 10, 20 hydrogens, so that works. Fingers crossed we can get our oxygen to work now. So 8 times 2 is 16. 10 times 1 is 10, so total that gives us 26 oxygen on the product side, and now we can multiply 2 by 13 to give us 26 oxygen there. So we are all good now. Do your one last check through to make sure everything does in fact even out there. So 8 carbons, 20 hydrogens, 26 oxygen, and 16 plus 10 is 26 oxygen. So we are all good there. Okay? So we're all balanced. Now we're moving on to question 26. Okay, so for question 26, we're writing reactions, then balancing them, then telling the reaction types. So we're putting everything together from Unit 5. The most important thing to remember when you're writing reactions is that all you're doing is really writing a series of chemical formulas and just stringing them all together. Okay? So you'll notice that for each of these problems, I'm going to have some scratch work above all of the formulas, above all of the names. So please make sure you're following along with those, because that's actually going to help us out with some of this, okay? All right, so when I look at each of these names, I have barium chloride. So remember that barium, when it was an ion, had a +2 charge, and chloride always had a -1 charge. Where am I getting those from? Go back to our Unit 4 video, and you'll see all of our rules about formula writing and so forth, okay? I know this is ionic because there are no prefixes, so what I'm going to do is I'm going to crisscross and bring them down, meaning that barium chloride will be replaced with BaCl2, okay? Now, it says it reacts with, so we're going to put a plus sign, aluminum oxide. Once again, aluminum oxide has no prefixes, so that means I need to worry about charges. Aluminum is in the group that always had a +3 charge. Oxide is oxygen, which always has a -2 charge when it's an ion. So again, if we crisscross our charges, aluminum oxide would be replaced with Al2O3. To form, so there's our arrow, aluminum chloride. So once again, I need my ions. So aluminum still has that +3 charge. Chloride is in the group that was always -1. And we might as well do the other one over here, barium oxide. So barium is +2, oxide is -2. Again, there were no prefixes in any of these compounds, meaning all of these were ionic. Okay? Now, notice that aluminum chloride would become AlCl3, and barium oxide. Both of these had charges of 2s, right? So really, we could have reduced that before we swapped. 2 and 2 would reduce to 1 and 1. So barium oxide just becomes BaO. Okay? So that's what we would call our skeleton equation, because it's completely written out, but it's not balanced yet. So what we also need to do is fill in these blanks in front to make sure we have our reaction balanced. Okay? So to balance this, I have 1 barium on the left and 1 on the right. So those are fine, there and there. I have 2 chlorines here and 3 here. So again, 2 does not go into 3, so we need to find a number that both of those go into. Again, that number would be 6. So to get 6 chlorines on the left, I'm going to put a 3 in front here. And to get 6 chlorines on the right, I'm going to need a 2 here. Now, we had fixed our chlorine. There we go. We had fixed our chlorine, 6 there and 6 here. So you could either keep moving left to right, or notice that this is going to make 3 bariums here, and now I only had 1 there. We had previously fixed it, but now we need to add that again, so we'll need a 3 there. Now if we check this out, 3 bariums, 6 chlorine, 6 chlorine, 2 aluminums, 3 oxygen, 3 oxygen. So we are all done. It would be 3, 1, 2, 3. And for our reaction type, since both of these are ionic compounds on both sides of the reaction, if we have 2 compounds on both sides of the reaction, that makes this a double replacement reaction. We have 2 compounds switching their partners to form new ones. Okay? So there we are with question 26. Moving on to 26A, Moving on to 26B, we'll do the same thing. So first thing, let's look at all of these compounds in our sentence, and then we'll start writing our formulas. So calcium bromide, no prefixes, so let's worry about charges. Calcium is +2, Br is -1. Then we see just an element, gaseous chlorine. Now the important thing to note about that is chlorine is one of the diatomic elements. So either think of the acronym HON17, chlorine is in group 17, meaning when it's by itself, we always have two of that atom bonded together. So we'd write it as Cl2, O2, H2, N2, etc. Or we also referred to the diatomic 7. If you start at element 7 on the periodic table and make a big number 7, you'll see chlorine falls in that as well. Okay? Our other substances are calcium chloride. Again, no prefix, so let's worry about charges. Calcium's +2. Chloride, when it's an ion, was just -1. And then our last thing is another element, bromine. Bromine is also in group 17, so we need to remember that bromine will also be diatomic. Okay? So keeping all of that work in mind, now let's write our skeleton. Okay, so calcium bromide. If we crisscross the +2 and the -1, we will get CaBr2, but it also said it was aqueous, so that actually goes after it, the formula in parentheses, even though it shows up before in the sentence. It always goes at the end. Reacts with, so we had just lone chlorine, but because it was one of the diatomic ones, we're going to put that little subscript 2, and it said it was gaseous, so we'll put our G afterwards. Forming aqueous calcium chloride, so let's crisscross our ions so we get our full formula, which would be CaCl2, and it said it was aqueous. And liquid bromine, if it was any other element, it would just be the symbol, but because it's a diatomic one, we write Br2, and it said it was a liquid, so there we are. Okay, so there's our whole skeleton. Now let's balance this. So let me put my dashes in front just to leave us some space. So to balance this, I have 1 calcium here, 1 here, 2 bromines here, 2 bromines here, 2 chlorines here, and 2 chlorines here. So this reaction is already balanced. So you can either fill all of these in as ones or just leave it as is, but that reaction is already balanced. So if you want to jot yourself a note, just so you remember that that's what you did, that's perfectly fine. So we could just write that off to the side if you would like. Okay. For our reaction type, I have, if I look at this, a compound and a single element. Yes, there's 2 of them, but it's still just one type of element. So a compound and an element, and then another compound and element on the other side. So this was an example of a single replacement reaction, because again, it's a single element replacing the other product. All right, moving on to our last question of the section, so 26C. This one, the reaction's already written out for you, so all we have to do is balance it and write our reaction type, actually. So, looking at this one, let's balance it first. So, I have 6 carbons here and 1 here, so first thing we'll do is put a 6 right there. Next, I have 12 hydrogens here and 2 there, so 2 times 6 gives us 12 there. Now the oxygen, if we look at our totals, over here I have 6 times 2, which is 12. Here I have 6 times 1, which is 6. So add that together, we get 18 total. And luckily, 2 times 9 gives us 18. So this one we don't have to go back and double or anything. It would just be 1966 when that is balanced. Last thing would be our reaction type. So since I have, Since I have oxygen reacting with a hydrocarbon to form carbon dioxide and water, those 3 in the circle are repeating, meaning this is a combustion reaction. Okay, so Unit 5 really does build on all the skills from Unit 4. So if you had trouble with Unit 5, it may be because you didn't do extremely well in Unit 4. If you're getting good and you really feel confident in your formula writing abilities, you should be able to put them all together to write chemical reactions. The biggest things that were new was the idea of the diatomic elements. So when they're by themselves, they always show up as 2, the element symbol with a little 2 next to it, just when they're by themselves. Also, balancing pops up again later as well. So if you had trouble with balancing, make sure there was plenty of practice from the unit. You could go back and relook at those as well. Okay, so there we are. Our next video will cover all the questions from Unit 6.